Hello there, it's Jay here from Jay's Vintage Junk, and today we're back on with the Merlin, the BT Merlin Tonto monitor repair. So we'll see if we can get the monitor working, and then we can see if we can get the computer itself up and running. And as we know, remember from the last exciting and dramatic video, the power supply here, which was the initial problem that we had, was a blown mains input capacitor there, which of you saw we replaced. We then powered it up, and we got all excited when it went bang. And I've been trying to find some a schematic diagram for this particular power supply. It's a Aztec unit. I keep saying Alps last time. The keyboard in this machine is made by Alps, but the power supply is an Aztec. Aztec made lots of power supplies for various different computer manufacturers in the 80s and 90s. I'm not sure if they're going, I think they're still going today, to be honest, Aztec. But this is a, I've got the model number here, yep. This is an Aztec AA12630 power supply, and I went online to see if I, to see if I could find a schematic diagram for this thing, and I was hunting around for information. One piece of information I did find was that this power supply was also used in one of the BBC micros. Not what you expect. It's not using like the Model B or a Master or anything like that. It was used in one of the more obscure BBC micros, which was known as the BBC Master Compact, which was it was basically a very small BBC Master that came with what they referred to as a monitor plinth, which actually contained a 3.5-inch disk drive and the power supply to run the whole computer. And apparently that used exactly the same power supply as this in there, but that is quite an unusual, even for BBCs. That's quite an unusual BBC. It's not something that every collector is going to happen to have sat in their attic. Me, however, I just so happen to have a BBC Master Compact sat in the attic, so I basically bit the bullet, and I've managed to do quite a lot of the tidying up there, so we are nearing being able to actually do videos back up there again. But I managed to get the monitor plinth, which is basically the disk drive unit, out of all my stuff. Now they did say, I then, before this anyway, when I'd found out that it was the same as a Master Compact, I thought, oh brilliant, I'll dig out the circuit diagram for a Master Compact and see if it's got any information on the power supply. And the only thing I found out from that was that they used two different power supplies. They used this Aztec power supply, and they also used a power supply from a different manufacturer, which is fine for in the Master Compact's use, but wouldn't have been any use to us. Fortunately, when I actually dug it out, my Master Compact uses exactly the same power supply. So this is it is identical. It is a Aztec AA12630. The good thing about this power supply is that Master Compact, when I bought it, I mean I've owned it for a few years, but I actually bought it as new old stock. It had never been used in a school or anything. So basically this power supply has probably got about 10 hours use on it. I have changed the, I did that when I first got the computer, because we know what these things are like. I did change the X2 mains input capacitor on it. Apart from that, it is completely original. All the capacitors are original on it. But I've just had a quick check over it, and everything is spot on it. It works perfectly. All the voltages are absolutely spot on it. So we do have a power supply that we can swap in. What it does mean is we stand a better chance of actually repairing the faulty power supply because we've got something we can take reference from. We can take reference voltages and things like that off the known good working power supply, and hopefully get this one that actually came out of the monitor originally working again. What I will say about this one compared with that one over there is this one seems to be that it was very, very high hours. If we look at the capacitors, that one round there, they've all been changed before on this power supply. If we actually look, on the bottom of it, I don't know how well you can make this out. If we just stand them both up next to each other. Now, bear in mind that obviously they've got a slightly different coloured conformal coating on them, but I don't know if you can see all the heat round here, the heat discoloration on the board compared with this one. That's like I said, this has literally got about 10 hours on it, because the only time that has been used was when I've been playing about with that Master Compact, and I don't even use the disk drive that came with it that uses this power supply anyway. I have a different disk drive I use with that has a 5 1/4 and a 3.5 inch on it. So literally that power supply is brand new. But like I said, having it does also mean that we can probably get this one working a lot easier. The other plus point is, if we can't fix this, if it turns out there's a shorted winding on one of the transformers or something like that, and it's not actually viable to repair it, it wouldn't be any issue at all to put another power supply in the Master Compact's monitor plinth disk drive unit, because all it needs is 5 volts and 12 volts for that application. This one doesn't actually use the -5 volts that the power supply can provide in that application. So we could just use any 5 volt, 12 volt power supply that produces a couple of amps, and that would be fine for there. So that's worst case scenario. If we can't repair this power supply, we do have now basically a brand new, or as good as brand new power supply that we could fit. And I was just about to actually literally just stick this in here and give it a go, but I thought, no, I'm going to be cautious, and it's a good job that I had, because it looks like this power supply actually failed for a reason. Now, the thing with these are fairly early switch mode power supply designs. What they don't have on them is things like overload protection and short circuit protection like modern switch mode power supplies have. And it looks like this died actually because there's a fault in here. I thought, before I'm going to put that known good working power supply in this, I thought I'd better actually just check some, do some basic checks, some basic measurements on this. So I got the old multi-tester out. Let's just get this thing set up. I've got that set on the 200k range. So I don't know if you're going to be able to make out what my monitor. Oh, let me see if I can zoom you in, see if you can actually. There we go. You can see that there now. And basically, what I did, we've got all the connectors on here that are basically either going down the wire to the actual computer or to the monitor, and it's more to the monitor that we want to be concentrating on. So the colour code basically is that purple there is ground, purple and orange is +5 volts, orange and black are 12 volts, and that one there, which is a thin just orange there, is -5 volts. Now if we go between ground, let me just connect this up. So if we go between ground there and the 5 volts, as we can see, we've got absolutely nothing. There's no shorts there, nothing. Go against the next one again, absolutely nothing. Now these are grounds, but obviously they're not connected through this. We'll try the next one, which is the smaller of the 12 volts, the little thin one. Again, we've got nothing there. But if we go on to the 12 volts there, if you look, we've got a dead short. So basically we've got a dead short on the 12 volt line. What we've got is we've got two boards in this thing. We've got this board at the front, which is an ICL board, which is quite interesting actually. I'll just show you this. What? Let me zoom you. Oh, you can see that okay, can't you? Yeah. Basically what you've got on this board here, this is what takes the RGB signal from the Tonto, and it converts it into a composite signal to feed onto the rest of the monitor here. Now there's a loads of resistors on here, and there's only one chip. Now I thought that was some kind of video combiner or something, but it's not. It's quite a weird chip that. It's basically a transistor array and then 3 transistors all in one package. And I have a feeling that's basically that, and these resistor networks is how they're actually combining the RGB and the H-sync and the V-sync and producing a composite output signal. I think that's how it's working anyway. Like I say, it's a bit of an odd thing. I was expecting to find like an RGB to composite just like a one chip solution, but like I say, it seems to be done with transistors. It's just they're all in one package like that. Anyway, let's get back to the fault finding in hand. So as we see, if I just connect this back up, we go on there, we go to the 12 volts. As you can see, we've got a dead short there. So the next thing to do is think, is the short on this board or is the short on the main board there? So the easiest thing to do is to disconnect this edge connector here and see what happens to the reading. As you can see, as soon as I disconnect that, we drop down to a 104k. Now that's a plausible resistance between 12 volts and ground. So that's showing, you know, that you've actually got some components there, active components there. Like I said, we plug the actual TV board back in, the monitor board back in. As you can see, we go straight back to a dead short. So sadly, it does look like lack of testing actually killed that power supply. What I should have done is, before I put the power supply back into the monitor, once we'd actually changed that capacitor, I should have really done that there. I should have checked on here and made sure it had no shorts or anything. But again, you get complacent with yourself. You think, well, I can see what's gone wrong with this. That's gone. It's obviously it's blown up. That must be the fault. But no, it looks like we've got another fault basically, and that's led us to having to rebuild this power supply. As where if we'd done a little bit more testing in the first place, we would have discovered that there was an issue on that, being able to sort that, and then hopefully not fry that power supply. Like I said, it's not the end of the world. We do have another one, and there's very, very good chance that we can rebuild that faulty one. But what it does mean is we've got to diagnose the fault on this thing now, unfortunately. Now this is a standard Philips chassis. I didn't even actually find the model number. It was stuck inside, but it fell off. So we do actually have, oh, that's focusing, but we do have the model number. I was upside down. You wouldn't be able to see that, would you? I've got an ICL part number for it, and I've got a Philips part number for it. Philips, it's a 3119208 which I'm sure someone in Philips must know what that means. What I really could do with again is possibly a circuit diagram for this thing. Hopefully, having that information, I might be able to find something. But it looks like we've got a pretty serious short. Like I said, we've got a dead short on here somewhere. I'm not going to be looking into it today. I will have to finish off sorting out the workshop, unfortunately, because it's going to be quite involved working on this thing. That board isn't particularly easy to get out. It's on these horrible little plastic tags, if you can see. And every time I try and take them things off, you end up breaking one, so you have to be really, really careful to release the board. Also, it's got a line output transformer actually on the main PCB there. I don't know if you can see that down there, the blue one. But it also uses what's either a doubler or a tripler to actually produce the high voltage needed for the CRT, and that's this unit here. That's what I don't know until I actually can see a model on it or a thing on it, but that's either what's known as a doubler or a tripler. It basically takes the high voltage from the EHT transformer there, which is like a high frequency AC. This has then got a rectifier stack on it, and it can either double or triple that voltage and then rectify it to the DC that's needed for the actual to drive the actual CRT. I'm hoping all that side of it is actually okay. There is one capacitor I can see in there which I'm going to have a look at. It's an electrolytic, and it looks like it's got quite hot, because it looks like, I don't know if you look on this, can you see, if you look on the top of a capacitor, on most capacitors, oops, that's my screwdriver dropped on the floor, let's get a different one. If you look at the plastic, you see how the plastic comes over the top of the capacitor there. Now what happens if the capacitors are heating up a lot and they're getting hot, it tends to shrink back that a bit, and there is a capacitor, and unfortunately it's really buried right in the centre of the board, right down there, and it does look like it's been getting hot, and the jacket on it's actually shrunk back a bit, so I'm wondering if that capacitor there is actually short circuit, and that's what's causing the issue on here. But unfortunately, to be able to do that, find that out, we need to pull this board out. There are also, I mean, these type capacitors here, these orange dips, very, very, very rarely have I found these go faulty. So I really don't suspect them to be at fault, but we do have a number of electrolytic capacitors on there which could be causing a problem. We also have the drive transistor, basically the line output transistor. Sorry, I was trying to think what it was called there then, which actually drives the line output transformer. Now if that's gone short circuit, that could cause the same problem. That could bring our 12 volt line crashing down to short circuit, so crashing to ground. So I think in the next video I'm going to try and get this board out. I want to try and avoid, if I absolutely can, having to mess with the CRT too much. If I can take the board out and be able to just flip it over and work with it on the top, that'll be so much better. But if not, obviously we'll have to discharge the CRT. We'll have to pull the doubler or the tripler. I'll have to find out whether it's a doubler or a tripler. That we'll have to pull that out of the chassis as well, and then we can get the main board out, and we can actually diagnose what's wrong with that board. Once we've got that board working, at least now we've got this known working good power supply, we can install that there and hopefully see how much progress we can make. So I'm fairly confident we will get this monitor up and running. The only thing that would be a real issue would be the line output transformer or the tripler, because I don't know where I'll be able to really get, or obviously if the CRT stuff, that might be an issue as well. But anything else is going to be an easy fix. Like I say, I've got loads of line output transistors, I'm sure I'll have one that's suitable. All the rest of the issues are going to be capacitors or things like that, really. I doubt there's even any bad resistance. It's probably a shorted capacitor or the shorted output transistor that's actually causing the issues now. Anyway, I hope you enjoyed that little update. This has actually dragged on far longer than I was expecting. It was literally meant to just be a quick 5-minute video, and it's already like 20 minutes. So I'm going to leave it there for now. Like I said, I hope you enjoyed that little update. Just show we are making progress with this, and like I said, that was a real bonus, finding out that I do have a replacement power supply. Long term, I am considering probably, once we ascertain that the whole thing works and we can actually get this one per desk, sorry, the Merlin Tonto up and fully functional, I will probably look at seeing if I can get it hooked up to a colour monitor so I can at least see it in its full colour splendour. But like I say, it will still be nice to get this original monitor up and running for initial messing about and testing anyway. So I'm going to leave it there for now. Like I say, I hope you enjoyed that little update. So thanks for watching, and goodbye.